November 121 Mike, your turn. Taxi 111.
Hi, I'm Mike Thompson, and welcome to 121 Point Mike. This is Ground School. We're near the end of the series on instrument mastery, and today I'm finally covering the one I wanted to when I first thought of this instrument mastery series, the VOR. I felt like I needed to cover the basic six-pack of flight instruments first, plus the compass. So here I am now finally doing the VOR. A very high-frequency, omnidirectional radial range is one of the ways that you can get where you'd like to go. They're being phased out, though, in favor of GPS, but there will always be a minimum operational network, or MON, of these around the country. They look like this and form the intersections of the highways in the skies. On the VFR charts, they're depicted like this, and like this on IFR charts. Sometimes they're combined with the military navigation. They're easy to identify because of the compass rose that surrounds them on the charts, and they usually have a bunch of airways leading out of them. Hopefully, you've seen the video on VFR charts, which I called VFR maps, because the VOR symbols are covered in there. This video is going to make you a master of the VOR, and not just for a test. I wanted to do this video for a long time because I think that using the VOR is fun, and it's important to know how to use this properly so that you don't get lost and crash. I've read that many people find them confusing, and I'm certainly guilty of occasionally dialing in the wrong number. So, I'm going to begin with how VORs work, and it's really quite simple. Imagine this. Well, just look at this graphic. There's a laser rotating at 1 degree per second, and every time that it passes through north, an omnidirectional signal, or light, flashes. So how would this setup be useful to you, long pause? Well, it can kind of tell you your relation in direction to the station. So let me explain if you haven't figured that out already. Wait for the omnidirectional flash, then start counting. If you know that the laser rotates at 1 degree per second, and you see the laser beam 30 or 90 seconds after the flash, then you know that you're somewhere along this line. Pretty neat, huh? If you saw the laser and the flash at the same time, then you know that you were directly north of the station, wouldn't you? There are an infinite number of radials leading out of the VOR, but we only use the whole numbers. It's close enough. And new digital systems can't tune fractional radials anyway, so yeah. Now, obviously 1 degree per second doesn't give you very good precision. It would take 6 minutes for the laser to go all the way around. And you can travel quite a long ways in 6 minutes, even in an ultralight. Yes, lasers and lights would be affected by fog and clouds and things, and light doesn't travel very far. So VORs use radial signals, and they rotate at 30 times a second to give you much greater precision. You can't travel very far in 30 milliseconds, even in a Blackbird. Now, there's a cone of confusion above the VOR where it's not able to give you a signal. As you pass over the VOR, your needle will start to deflect to the limit and probably twitch. You'll get a flag perhaps, and then finally your arrow will flip from a to a from, but don't overcorrect as you fly over it. Maintain a heading that you're supposed to, and wait a bit after you pass the VOR before you start to make any serious course corrections. Don't over-control your plane. There are also several types of VORs that you might need to know for your test. There are terminal, low altitude, and high altitude VORs. Each of them has a maximum radius that it's good to and altitude. Terminal VORs go out to 25 nautical miles and up to 12,000 feet, therefore terminal areas. Low altitude VORs go out to 40 miles and 18,000 feet, which is the bottom of Class A airspace. You're going to need an instrument rating and be on an IFR flight plan to go any higher than that. High altitude VORs, they're basically a low altitude VOR up to 14.5, and then they expand out to 100 miles up to 18,000. Then they expand all the way out to 130 miles up to 45,000 feet. But then they shrink back down a bit up to 60,000 feet at 100 miles. Of course, none of that really matters. If you're just doing flight training, yeah, the top half of that doesn't matter to most of us. You need to be in a decent-sized jet to get up there. Okay, so now you know how the ground station works. But then there's the receiver in the cockpit, and that's where the confusion happens. So I'm going to attempt to demystify this on the road to mastery. You have to tell the receiver which radial to listen for. On the older round style gauges, you rotate the little knob. This has the unfortunate name of Omni Bearing Selector, or OBS. The French didn't go to hold of that name, obviously. That one's uniquely American. The Omni Bearing Selector is a knob that rotates the little compass card around the perimeter of the instrument, and it will listen for whatever number is at the top. That number represents the radial coming off of the VOR, which is the difference between the two rotating signals, the flash one that I mentioned and then the one that rotates. So that you can use this knob to listen for what radial you want, and then it's going to display your orientation on that needle. If the needle is centered, then you're on your selected radial. Each dot represents 2 degrees, so a full deflection is 10 degrees right or left of your course. Each dot is 2 degrees. Each dot is 2 degrees. You might see that on a test. Now, what about these arrows over here? Well, those are your to from indications. The radials listed on the chart are always listed from the VOR. And this little flag here is what causes people to kind of miss test questions and possibly get lost in the air. So I'm going to hit this really hard with some scenarios and examples for you to think through. First off, let me point out that the VOR has no idea which way your aircraft is pointing. So your compass heading does not matter to the VOR. Direction is totally irrelevant. I've said that 3 different ways now, so hope you've got that. The VOR has no idea which direction you're pointing. That's 4. If you're north of the station and you dialed in 360 radial, then the VOR will show you on course no matter which way you're pointing. Now, if you're heading any direction that's not along that radial, it will show you off course soon enough. So, what about the to from arrows? Well, that depends on what you've dialed in on top. As I've said before, that the radials are labeled from on the charts, and so I'm going to cover that first. If you're heading east, say on the 090 radial away from the VOR, then you will dial in a 9 at the top. Imagine your plane in the center of this instrument, and then the needle is your road. Road. If the needle is to your left, then your course is to the left. You turn left to get back on course. Here you can see that we're 4 degrees to the right of the course, because the needle is 2 dots, right? Every dot is 2 degrees. Now, we can't just turn 4 degrees left, because that won't get us back on course. We'd simply be paralleling our course, and that's going to be a test question, and paralleling's not good enough. We always want to be on course, unless we don't. The rule of thumb is to double your deflection. Double your deflection. Double your deflection for correction with double mint gum. So, we turn 8 degrees left until the needle centers, then we turn right those 4 degrees back on course. Now, here's some stuff that you're certainly going to see on a test, and probably in real life. How many degrees is a dot on the VOR? Let the record show that I'm holding up 2 fingers. This test will also ask you about the sensitivity of a VOR. Well, since the VOR is radials based, the linear distance between the radials gets closer as you get closer to the station. The distance between radials is 1 mile at 60 miles. The distance is 1 mile at 60. 1 to 60. We'll come back to that in just a little bit. In your private pilot training, you'll be required to do some instrument work, and you'll have to make several cross-country trips. And you'll need to know how to use the VOR to find your position. Actually, you'll need a pair of VORs, but not technically. So to find your position, you really only need one, and that's a possible test question. I saw that on a commercial test. But having 2 receivers is certainly handier, so you can tune them at the same time. Now, here's how you do it. You tune your nav1 radio to a VOR somewhere along your route, and then you rotate the OBS until the needle centers with a from indication. Do not use the to indication. That can lead to confusion. So make sure you're in the habit of dialing in a from indication when you're finding a position. Then you tune your nav2 radio into another VOR along your route, preferably at a right angle to your route so that you get the greatest precision. And then you center its needle with a from indication. You draw 2 lines, and that X marks your spot. Now, if you don't have a nav2, then you'll put your VOR frequency for the second one in your standby, and you'll have to swap it over. Your position will still be pretty close as long as you don't wait too long between shooting your 2 bearings. Always make sure that you have a from indication when doing this, though. Let's do this one more time.
If we're outbound from St. Louis on the 031 radial towards Springfield, Illinois, we can see we're on the Victor 9 radial, and this VOR over here, the VLA, is probably pretty good. Better than this one over here, because it's more at a right angle and closer to our course. So, if I grab my ruler here, I can't find my plotter, and let's say we get a 2.9 or 5 from, then we know we're right here, over Palmyra. Pretty neat, huh? And of course we could do that for any place along the route. Now on the Victor 9-4 radial, you can see here that we use this Marvel VOR to identify the Crink intersection on radial 122. We could also identify it with the 43 DME from the Holly Springs Vortex. So Marvel 122, if I get my ruler out here and draw a line, let's say we get a, if we get a 135, you can see we're about halfway between these 2 intersections along this 24 nautical mile leg. So that's how you can plot your position, shooting your bearings to your VORs.
Now, here's why I'm harping on this from thing so hard. It's because the 2 from flags are what can get you lost. The term you might see on a test is reverse sensing. Reverse sensing. Reverse sensing. I'm going to explain that now. Let's go back to our example where we're north of the station and heading north. We should dial our VOR to 3.6 and with a from indication. But it's also going to show you on course if you're on the 1.8, and this is a reciprocal course. It will show you as on course, but the needle will reverse sense. Ordinarily, we double our deflection and turn toward the needle to get back on course. But if we do that in this case, we'll go farther off course. It's reverse sensing, and we'll need to drag our needle back to center. This confusion causes many headaches on a test and in the air. We should always try to set up our OBS so that we're never reverse sensing. Now, some electronic displays don't have this problem. They're correct no matter which way you're headed, and I'll have to cover those later in a different video. The old steam gauges, though, they're not smart enough to know any better. Now, the one time I can think of when I purposely use reverse sensing is on a back course approach, and they're disappearing though, and they only pertain to you instrument-rated pilots, but it's important to know, and I'll note it here, as I just did. And so I'm going to talk about that more though in the back course instrument approach video. So I'm going to go through a bunch of examples now so that you can really understand how to master the VOR. I find the complexities of using them kind of fun and way more interesting than just following a magenta line. Let's get out our sectional chart and we'll fly a few legs.
We're inbound to Topeka on the Victor 77 airway. You can see that the radial is labeled 231 from the Vortex, but we have our OBS turned to 051, which is the inbound course, because we don't want reverse sensing, right? We keep the heading and the OBS in the upper half of the instrument to avoid this. I've also got a 2 arrow, so I know that everything is set up correctly. Now, you'll also see my heading is 055, which is 4 degrees to the right of my 051 course. This is because there's a wind out of the south, and I have to set up a crab to compensate for the wind. If I were to head 051, I'd be blown to the left, and so I maintain a crab angle inbound to the Vortex, and all is well. Now, I'm going to set up for my turn outbound toward Kansas City. That's on Victor 4, which is the 072 radial. About a half mile from the VOR, I'm going to start my turn to the right so I don't overshoot, and turn to a heading of maybe 078 to compensate for the wind. I expect to use a larger crab angle because it's more of a crosswind now on this new heading. There goes my needle, so I'm going to begin my turn and change my OBS to 072. And we get the flag as we pass over the cone of confusion over the VOR, and I'll maintain 078 and wait for the from flag for a minute or so. I'll make corrections as needed to stay on course, and since this leg is 39 miles long, I'll stay on the Topeka VOR tack until 20 miles out. Then I'll switch to Kansas City, and I don't need to change my OBS at all because 252 and 072 are reciprocals. Then, as I approach Kansas City, I'll prepare for the outbound leg toward the Bremer VOR DME. As my needle goes, I rotate my OBS to the 057 outbound radial and turn left. I'll then fly from Kansas City. Now, if you've got a NAV2 radio, I recommend putting your next waypoint in it so that you don't overshoot or undershoot your inbound course. Let me show you why. The inbound course to Bremer is 060, which is not the 057 outbound from Kansas City. So, I'll set up my NAV2 for 060 since the Bremer radial is 240, because I want the reciprocal course inbound so I don't reverse sense. When my NAV2 needle centers, I'll turn slightly and fly that leg inbound to Bremer. Now I can swap frequencies and rotate my OBS on NAV1 to Bremer. Now NAV2 can be set up for the next leg. Sometimes an airway will bend in between VORs, and this is when having a second nav radio is helpful. You'll set it up just like I mentioned, and then you'll turn when your NAV2 shows you on course. If you only have one nav radio, then you'll have to set up your next VOR in the standby frequency, and then swap between them and rotate the OBS back and forth as you near your turn point. It's more work, but it's not bad. Just make sure that you tune the correct radials back and forth when you swap frequencies. You typically swap VORs halfway between them. Swap in the middle of the leg. Switch halfway. That will be on a test. And so that's how you fly legs with VORs.
The point is, en route, your compass heading and your VOR OBS should be in the same half of your heading indicator. If they are, then you're not reverse sensing. Say if you're heading 220, then your OBS should be set plus or minus 90 degrees from this to avoid reverse sensing. Now on a test, you're going to see problems like this and asked which airplane is which.
I'm going to feature that in a VOR practice problems video though, because this video is already long enough.
Now the last thing I'm going to cover are times and distances to station problems, because they're going to show up on a test, but I've never needed to do one in real life. The thing to know geometrically here though is that at 60 miles, the radials are 1 mile apart. Each radial is separated by 1 nautical mile, 60 miles from the station, and that applies to VORs or NDBs, or anything really. 60 to 1, this is important. You might be asked to determine your distance to the station, say if you're crossing the 270 radial heading north, and you are flying at 90 knots, and then you cross the 280 radial 5 minutes later. How far out are you? Pause the video now if you want to try to figure this out before I give you the answer. The first thing to find out, of course, is how far you travel in those 5 minutes. Well, if you were going 60 knots, you'd travel 5 nautical miles, wouldn't you? But you're going 90, so it's 1.5 times that, which of course is 7.5 miles. Now, the problem said that you crossed 10 degrees. If you crossed 10 degrees in 10 miles, then you'd be 60 miles out, right? 1 degree per mile at 60. But you crossed 10 degrees in only 7.5 miles, so you must be closer, because the radials get closer, right, as you get closer to the station. So, this must mean that you're only 7.5 over 10, which is 75% of 60, and that happens to be 45 miles. So, there's your answer. Let's do another one set up in a similar fashion. If you're flying at 030 and cross the 120 radial at 1205, and then cross the 115 radial at 1207, how far out are you at 120 knots? Well, first we need to realize that we're flying exactly perpendicular to the VOR, and that instant we cross, it should be exactly off our left wing. The difference is 90 degrees. And so now, it's behind us slightly. But we know it took us 2 minutes because we ran the clock for 2 minutes, and we can do clock math. We crossed 5 degrees in that amount of time, and we're flying at 2 miles per minute. So, we traveled 4 miles in those 2 minutes. At 60 miles out, we'd expect to cross a radial every 30 seconds. And at this speed, so 5 degrees should take us 2.5 minutes. But it only took us 2 minutes, so we're closer, and so we're expecting a number smaller than 1, right? 2 divided by 2.5 is 0.8, which is less than 1, which means I divided correctly. And 60 times 0.8 is 48 miles, and that's the answer. I like to think of it in terms of the 60-mile reference number, and it helps me avoid making mistakes. And I suggest you do the same. But of course, if you come up with something that helps you out, then certainly do that. Now, why does all this matter, really? Well, in real life, it doesn't. It's just guaranteed to show up on a test. And I've never found a reason to do it in real life because I hate turning off course on purpose. Okay, so let's do another one set up slightly differently, and I'll show you this little secret for finding out an answer really quickly on your test. If you're tracking inbound on the 180 radial, and you turn 10 degrees to the right, and then cross the 170 radial 3 minutes later, what's your time to the station? The secret, without having to use any fancy formulas, is to realize that this is an isosceles triangle. If we draw this out, you'll see that your course was this. You turned right 10 degrees to intercept the 170 radial, which is here, and see how these radials are 10 degrees apart, and so you turn to intercept it, and if these angles are the same, then you have an isosceles triangle. And that means that these two legs are the same length and in case the same time. If it took you 3 minutes to go here, then it must take you 3 additional minutes to go there. And as long as your speed hasn't changed, then the times are the same as well. I am not a fan of these types of problems because they really have no practical use in the real world, but you're going to see them on a test. And so you need to know how to do them. After watching this, you should hopefully know how. I'm going to put up a couple of test problems for 10 seconds that you can use, screen capture them or whatever you want to do, and then print them out. And then I'm going to put the answers at the very end after my sign off. All right, well that's about it for VORs. They're certainly more complicated than NDBs because they have the OBS and 2 little flags that can easily get you lost. However, once you master the VOR, you'll find that its challenge, I think, is quite fun. I still like to fly them if they're somewhat on my way. Go ahead and subscribe if you haven't already, and you can be notified when the next video is out. It's also a great way to help me out and grow my channel. Another way you can help me out, of course, is to leave a comment down there. I'll respond to as many as possible. And stay with me on 121 Point Mike.